positions of the x. So instead of writing 4 and 3, you write 5 and -1, and then you keep the other two numbers, and you have to calculate the determinant of this. So 5 times 1, you're multiplying the diagonals, minus multiplying the other diagonals, -1 and -2. This ends up equaling 5 minus 2, this time, or 3. And then there's one more dy. This time, you take the 5 and -1 and you replace it where the y is. That's why it's called dy. You replace with the y. So it's 4, 3, 5, -1. All right, so the determinant here is 4 times -1 minus 3 times 5. -4 minus 15. -4 minus 15 is negative 19. Okay. Doesn't work out so nice. That's okay. Any questions what we've done up until till now?
No.
Okay. So the next part is actually not too bad at all. The solution x, like, well, that's what we're trying to find, x and y. X is the value of dx over d. So it's 3 over 10, 0.3. And then y is dy over d minus 19 over 10, or minus 1.9. So in some ways, this is better. You just find the determinants, write the ratios, and you're done.
Okay.
All right, so it says to check your answer using another method learned in class. I'd like you to graph these in Desmos, and then hopefully the intersection point is 0.3 minus 1.9. So will you graph that for us, please?
Yeah. Yeah, it passes through 0.3 and negative 1.9.
Good, so there's your solution. So the idea is you're sort of armed with all these different possibilities for how to solve equations. So good job on that. We got one more problem in this problem set. This is the apply your knowledge, and we'll look at it now. I'm not snipping in the sort of the dancing pear and apple. I don't know. All right, Jim buys 7 apples and 4 pears for $7.25. At the same prices, Hannah buys 5 apples and 9 pears for $10.40. What is the price of one pear? All right, so the idea here is that it is the price times the quantity plus the price times the quantity equals the total cost. And so interestingly is that in this problem, the prices are the variables. So the price of an apple is A, and the quantity of apples is 7. This is the equation for Jim. The price of a pear is unknown, so we'll call that P. The quantity of pears is 4, and the total cost is $7.25. So this one's just backwards of what we're used to, but it still works out here. Okay. So Jim buys 7 apples. There's the 7, there's the 4 pears. Total cost is $7.25. Will you attempt to write the equation for Hannah?
Sure. So it would be A times 5
Okay.
plus P times 9 equals 10.4.
Really good. Now this is it's a little awkward because the number almost always precedes the variable. So we're just going to rewrite each equation. 7a plus 4p equals 7.25. 5a plus 9p equals 10.40, like that.
Mm-hmm.
All right, now it wants you to find the solution using Kramer's method. So again, we have to create 3 matrices. D is called the coefficient matrix. It's the coefficient of the A's and the P's. So 7, 5, 4, and 9, like that. And then because we only care about the price of the pear, you look back up, it just says, what's the price of one pear? It doesn't say pears and apples. We only also need DP. DP is the coefficient matrix like we just had, except you replace the right-hand side where the P's go. So it's 7, 5, 7.25, 10.40.
All right.
So just like the previous problems, I want you to find the determinant for both these. You can use a calculator. You're multiplying the diagonals, 7 times 9 minus 5 times 4.
Okay. So hold on. You want me to do what again? I'm so sorry.
Yeah, just calculate the determinants. Let me go back up and show you how we did it in the previous problem. You take the diagonal 4 times 1 and multiply it by the other, and then subtract the other diagonal product. So 4 times 1, you multiply 3 times -2, and then you subtract the difference. So if you need to, you can sort of, we might have even drawn this just a butterfly. You're multiplying those and multiplying those. And so
So
in your,
so it would be 7 times 9 minus 4 times 5.
exactly, yes. Let me know what you come up with for that.
So for that one, the answer would be 43.
Okay. And then do the same thing for the other one, please.
Mm-hmm. For that one, we would get 36.55.
Okay. Yeah, don't fret too much. It's just a number. You
Yeah,
you have to use it in the next part of the
I'm by
problem.
surprise.
Say that again.
It just kind of surprised me because I was like, oh, okay, that works. I'm surprised. That
So
was
the value of P is the ratio of dP over D. So those two numbers. This one does work out nicely. So go ahead and meaning it's a reasonable number in terms of money. So go ahead and calculate that and let me know what you come up with, please.
that would be 0.85.
So you might write somewhere that the price of pears is 0.85.
Mm-hmm.
And that is it.
Nice.
All right, so I'm going to load up the next problem set. Whenever you get a chance, just I'm going to actually send over a reference to that. Actually meant to send this over to you yesterday, but that's okay. Yeah. All right, just let me know when you're ready for this.
All right, just give me 1 second. I'm just sending this to Cam Scanner. Uh, so yeah. All right.
So, all right, we're in the land of conic sections, and conic sections are they're very difficult. You may think like, well, everything we've been doing has been difficult, and that's true, but they're sort of unbelievably difficult. Um, I always send students this reference sheet, and you don't really need it the way your class is structured, but I'd send it anyway in the chat. There are 4 different types of conic sections. So the first one is, and you already know about these, are circles. The second one is parabolas. The third one is ellipses. And the last one is hyperbolas. And you might be wondering, well, what do these things even look like? And this reference sheet does a really good job of actually showing you. So all conic sections come from taking 2 cones and slicing them in a certain direction. So the circle, you know what a circle looks like, but the parabola is this cone cut by a plane. Think of it as a sheet of paper, and the red line is the conic section there. So that's shape 1. The ellipse looks most like a circle, and it's one that goes again kind of through the cone, but at an angle. And so it looks kind of oblong or an oval, you might have heard in a earlier course. But a circle is when you cut it perfectly straight. and you get a nice uniform circle, which I didn't draw very well, but that's the idea. So that's the difference between a circle and ellipse. And then the last one, kind of the one, you probably don't hardly ever see, although they're really important in applications of math and science and engineering, are hyperbolas. So hyperbola is when you cut the cone top and bottom. So you get kind of this parabola up and parabola down. You can think of it as two parabolas.
Mhm.
So to do this first problem, the way we're going to do it, actually, I should look at the notes. I was going to just have you graph it. Let's see what they actually want you to do here. Oh, and actually they do a really good, I didn't even notice this because I rarely look at those notes, but they do a really good job of showing you the possibilities here, which is great. So I mean, if you have time, watch the videos. All right. So yes, you can just graph. You can just graph this according to the notes or the example. So go to your Desmos, go ahead and graph this, and decide, does it look like a parabola, a circle, an ellipse, or a hyperbola?
Okay.
And it should be kind of obvious. Now, I'm going to do the same thing, but it's kind of a self-discovery exercise.
It's a circle.
Okay, so the circle and the ellipse look really similar. So when you look at this one, does it go up, down, left, right the same amount? It has to be exactly the same. So see how this one's just a little bit above the 2? How
Mhm.
about over here? Is it just a little bit above the 2?
Yeah.
I would say it's a little more.
Oh.
Like, do you agree that this point and this point are different distances from the 2?
Yeah.
Okay, so this one would be considered an ellipse.
Mhm.
All right, so I would include the graph like they're asking for, and you just have to classify the shape. Say it's an ellipse. Nothing more to do on that one.
All right.
All right, so now you're going to create a new graph. We're going to create a new graph. So go to your Desmos again, go ahead and graph this, and then decide, okay, well, what is it? Is it a parabola, circle, ellipse, or hyperbola? Again, should be kind of clear when you look at it, but compare it to your notes there.
It's a parabola.
Okay. Let me graph it here. I was expecting a different answer.
Maybe I
So
said the wrong.
you're saying you just see this.
No. Oh no, it's different. It was. Mm. Oh, okay. Because I was looking at my notes, and when I put the graph in, maybe I put in the wrong number. Hold on. No, I didn't. Oh, because when I put the graph in, it looks like that. Yeah.
Okay, so this is two parabolas. So when you see two parabolas, that's a hyperbola. One parabola is a one parabola, two parabolas is a hyperbola.
Oh, okay, got it. The names are confusing, but I know remember them eventually.
Yeah, I mean, you'll see this once in this course, maybe again in pre-calculus, but not a big deal here either way. So
Maybe.
there it is. You're going to say the word, you're going to write down hyperbola, include the graph, and that is it. Nothing more to see there.
All right.
Now you might think, up, I got it. No big deal. We're going to race through this lesson. And then the real stuff starts. So, right. So number 3. All right. Name the center and the vertices of the ellipse. I sent you that reference sheet, and this is so like the typical math course will cover 1 day circles, 1 day parabolas, 1 day ellipses, 1 day hyperbolas, and we're doing it all in like 15 minutes. So this is way too fast to ever learn this, but it is the case here. So you have to decide whether this is a vertical or a horizontal major axis. And if you stare really hard at both of these, the only difference you notice is that one has the b squared under the x, and the other has the a squared under the x. And in this one, a squared is under y, and b squared is under y. And you're like, well, how do I even know? And well, the answer is you don't have enough information. So the answer is the ellipse has this relationship where a squared equals b squared plus c squared. And you're like, well, that still isn't very helpful. Here's where it is helpful. A is greater than B. A is greater than B. The other thing you should notice is that in both of these equations, there's a 1 and a 1 there. Okay, and in your equation, you don't have a 1, you have a 45. So we need to manipulate this equation a little bit. All right, so to do that, you divide both sides of the equation by 45. Because you really want a 1, on the right-hand side. Now you have it. All right, now 5 divided by 45 is 1/9. So this is x squared over 9. And then 9/45 is 5, y squared over 5. So this equation we've written here is the same as the original, but it's now in the form that you can work with. So which is bigger, the 9 or the 5?
The 9.
The 9, right? It's a simple question once you get that. That means you have a horizontal major axis because 9 is greater than 5. But really, and this is where it gets more complicated, you want to rewrite 9 as something squared. So 9 is really 3 squared. 5 is really the square root of 5 squared. And the whole idea is to make it look like this thing on the right here.
Okay.
So I know it's like a long setup and a short punchline. So the equation is x squared over 3 squared plus y squared over square root of 5 squared equals 1. And this is a horizontal major axis, okay? So to find the center and the vertices, we have formulas. All right, so I'm going to snip those in next. All right, so the ignore these are the wrong ones. The ones on the right are the correct ones. So the center is at h comma k. Okay, h comma k. You're like, what's h and k? Well, h and k are the numbers that are being subtracted from x and subtracted from y in the numerator inside parentheses. Do you see anything inside parentheses here?
Yeah, on the
On the top, yeah.
um,
No. So actually in your problem, h and k are 0, which is nice. So your center is 0, 0. All right, so now for the vertices, you need this A. You need this A, and that's what the whole business of why we're trying to figure out, well, is it A squared above over the below the X, or B squared below the Y? Which one is it? We know that A is really 3 in your problem, because it's A squared, 3 squared is A squared, A is 3. So to find the vertices, you say, okay, it's 0 plus or minus 3 comma 0. But that's really 2 vertices. It's 0 plus 3, 3 comma 0, 0 minus 3 minus 3 comma 0, like that. So at this point, I just expect you to sort of follow the steps. I mean, I would never ask you to do this on your own. This is way too hard right now to understand all this stuff without any introduction. But hopefully you see we find the variables, we put them into the equations and get some things out. The next thing is the to state the vertical and horizontal axis and how you determine that. We actually did that first. You actually have to do that before you can do anything else. So the horizontal major axis. A graph, oh, we already have the graph. The graph is up here. See how the horizontal one is wider? That's another reason how you know which way it is. All right, so I think we've done everything here. We did the center, the vertices, we did the horizontal axis. Oh, we actually have to how do let me look at your notes and see if your instructor does anything like actually specify that it's y equals 0. It does not. Okay, so we've got it. You just have to say horizontal. Any questions on that?
No.
Okay. So moving on to number 4, stop and think. These are more like stop, think, ask someone, and then do. They're quite challenging here. All right, so here we go. New problem. New problem here. So you should always go and graph these first. So I'd like you to go to Desmos and graph this, and tell me what you think it is.
Oh, right at the graph it is. It's again a circle.
This one is definitely a circle. Okay. So one way you can say how you determine that is that you graphed it, but more importantly is that it has this form for a circle: x minus h squared plus y minus k squared equals r squared. Okay, now the center of the circle is h comma k. Could you look at your graph and tell me where the center is?
The center,
Just looking at your graph, where's the middle of it?
somewhere like it's in between the 4 and the 6, like the pocket. I don't. I actually don't know. Maybe the center's 5.
The center is two coordinates. It's an x and a y. What's the y value?
Yeah, I don't know.
Well, you were able to find the center on the x side. Do the same thing for the y.
Uh, so wouldn't it be like 5, comma, -8 maybe.
Okay, and you're graphing x minus 5 squared plus y plus 2 squared equals 36.
Yeah.
Okay, pretty sure -8 is not inside the circle.
Oh, then would it be like, oh, then maybe it's,
Like
well,
when you're skating and someone says to go to the center of the
there's a dot so you can find the center.
right, but the point you just gave me is up in the stands. So give me,
Yeah, I don't know what the center is. I'm like, is it 5, comma 4?
okay, so I'm gonna graph a different circle. uh, and hopefully we can find it here. Okay, so I'm going to snip this in. And one of the one of the things about Desmos that does kind of work at a little bit of a disadvantage is like unless you zoom in, you don't see it. But if I just said, well, where's the center? I'd hope you'd say it's about there. Okay, and if that really doesn't work, you can draw horizontal lines. I know you can't draw them on a digital screen, but you can sort of use your finger or run it down there. Where is that coordinate?
Oh, it's in like, mm, 3, comma, negative. Wait.
Okay, I agree. 3, -1. Now you got your graph in front of you. Do the same thing to find the center.
Okay. Okay, would it be 5, comma, -2?
Yes,
Okay, I figured it out eventually.
yes. So your original point that you told me was like down here. And I guess I don't know. I didn't know how to respond to that other than to say, let's try another problem. The center is the center. It means go right to the middle uh, of the object. Okay. Now it says to name the center. We've done that. You got the center. How you determine that, you could say graphing if you wanted. And then the shape, it's a circle. So I think we've got all of those completed.
Okay.
Now, the thing we got to be really careful of here going forward is to do it the way that they want. Although I guess all your assignments are open, so I don't know how important that is at this point. Because a lot of these I would just tell you, let's just go and graph. Let's just go and graph. And this one we can't graph, but most of the other ones we can. So I guess it doesn't actually say to refer back to. That's good. That's good. Okay. All right. What is the standard equation of the circle? So I actually just wrote it here. I'll write it again for you. X minus h squared plus y minus k squared equals r squared. The first number is h and the second number is k. The radius is given as 5. So we take those values and we put them in, oops, not there, there, and then the 5 and there. So it looks like this, x minus a minus 5. X minus a minus 5. The reason it's two negatives is that h is independent of the subtraction operator. It's totally independent. Now, in this case, you have to combine the two negatives, x plus 5 squared like that. Now you try the next one here. Tell me what the result is after you put in k into this equation.
So it would be for the next equations it'd be like y minus -1
Okay,
squared.
very good. Now, can you simplify that?
Yeah, it would be y plus 1 squared.
Good. And then the radius is given as 5 squared. 5 squared is 25. This last line here is your final answer. Any questions on that?
No.
Okay. All right, so to do 6, we are going to graph it. I'm just going to write it a little bit differently. It's x squared over 25 plus y squared over 9 equals 1. And I don't know what this looks like. It either looks like this or it looks like this, but there's a point at the top, the bottom, the left, and the right. Top, the bottom, the left, and the right. And that's what your instructor wants here. They want the top, the bottom, the left, and the right. So I'd like you to graph this and give me those ordered pairs, please.
What? Oh, vertical? Okay. Um, so all the pairs, so like from this circle, right? Wasn't really.
It's not a circle, it's an ellipse. It's an ellipse. First of all, it's important to we know which. So does it look more like the one on the left or the one on the right?
The one on the right.
Okay. So you have to identify, and Desmos allows you to basically just click at those positions. Click, 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 and click, and hopefully you can. They're nice points. Hopefully they're integers, and they are in this one. So just click at each of those positions and see if you can give me the vertices.
Okay, so the vertices are 0, 3. Another one is 5, 0. Another one is 0, -3.
Yep.
And the last one is -5, 0. There you go.
Right. So that is everything for this problem. We'll be able to do the same thing for the next one. Right, identify the center of the conic hyperbola whose equation is, so just a little bit better way of writing this is x plus 2 squared over 9 minus y minus 2 squared over 16 equals 1. And your graph will look something like this. It'll be either be an up and a down, or it'll be a right and a left. And in either case, there's a line that goes right down the middle and another line that meets if it's what's called the center. Same thing here. You're going to have, and you have to draw these. You have to sort of estimate where they are. So go ahead and graph this.
Okay, so looking from the hyperbolas, it's the second one.
Okay, it's this one over here on the right.
Yeah.
Okay, so you have to then sort of estimate kind of where this horizontal line is and where this vertical line is.
I think it's at like 0, I don't know actually, hold on. But it looks like from the line that you drew, it looks like it's at 0, 0, but like,
I just made it. This is not your graph. I just hand sketched this. I'm asking you to look at what you see on your screen and estimate the middle, and then the middle.
I think the middle is -2, 2. Just
That is correct. Yes.
yay.
All right. So you can say the center is at -2, 2. Make sure you include a sketch. So before we do 8, just like I was trying to show you here, there's 2 possibilities for hyperbolas. They either open up/down, or they open left/right. And the next problem asks you to determine that. So again, you just want to graph them and then say, well, here's a picture of the graph, provide a picture of the graph, and then say whether it opens up or down or left or right.
All right.
So this one is x squared over 9 minus y squared over 25 equals 1.
Okay. Now I have to find the center.
This one does not ask you to find the center.
Uh, how,
What does it ask for?
how does each graph of the hyperbola open? Um, I don't know how it opens.
All right. You remember me talking about this like 2 minutes ago?
Oh yeah, found it.
This is the second time today I've showed you something and then just you've had no idea. So please like try to just, I mean, I'm doing my best here to help you figure this out. Like I can't make it any more clear than this. You just have to graph it and
Oh,
then decide, does it look like this one on the left or this one on the right? Like,
it's the one that opens like the left and right one. It's
okay.
the,
All right. So what I would do is include, because it keeps asking how you know, include a graph.
yeah. I just like
And then you can just say, well, it opens left or right, and then you're done.
yeah.
All right. So we are out of time, but if you want to, we're going to do another hour here in about 10 minutes, but always good to take a break. If you want to, you're welcome to graph this one. It's exactly the same as the previous problem. You just graph it, decide whether it opens up or down or left or right. You can wait to do that, but looks like we'll be able to finish this section here in the next hour and move on to the review assignment. So we're in good shape. We're going to go ahead and stop there for right now.